A while back, I did a video on prompt injection, the thing where you hide instructions in text that an AI will follow. At the end of that video, I said this: there are credible reports that YouTube is using LLMs to evaluate video quality, and if that's true, then every video on this platform is also a prompt. This transcript, right now, it's being read by an AI that decides who sees what. That was a half-bit, half-genuine question when I recorded it. I was doing it mostly as a joke, but I got a little more curious about it, so I dug in. And it turns out they actually published a paper on this and gave a whole tech talk explaining how it works. The way they're doing it is nothing like I imagined. They didn't bolt an LLM onto the old system. They rebuilt the fundamental unit of how videos are represented. They invented a whole language. Start with the most basic question a recommendation system has to answer. How do you even refer to a video? A video, a song, a product, it needs an ID. And for decades, the move was the same. Assign it a random number, hash that into an embedding, done. That works fine for the hits. Millions of people watch a video, the model gets plenty of signal, it learns what that ID means. But the IDs themselves are meaningless. Cat playing piano number 47 gets one random string, number 48 gets a totally different one. To the model, those two are as related as a phone number and a zip code. Nothing connects them. It's like running a library, where every book gets a random shelf number. No sections, no Dewey Decimal, no grouping by subject. The popular books, the staff just memorizes where they are. But anything niche, anything that came in yesterday, effectively lost in the stacks. And YouTube is a big library. 20 billion videos, with millions more added every day. Almost none of them will ever be popular. But somebody, somewhere, wants each one, and a random ID gives the system no way to find it for them. So about 2 years ago, a team at Google asked a different question. What if the ID wasn't random? What if the ID itself told you what the video was about, so that similar videos got similar IDs? Here's how. Take a video and pull everything you've got. Title, description, transcript, the audio, even sampled frames. Crunch all of it into one long list of numbers that captures what the video actually is. Then compress that list down to a short sequence of integers, about 8 of them, in a way where similar videos come out with similar sequences. The compression is worth seeing because it's kind of pretty. Think of describing a painting using a stack of shared reference books. Book 1 is broad, a couple thousand reference images. You flip to the closest match. Page 147, landscape. Write down 147. Then subtract that reference from your painting. What's left over, the residual, is everything page 147 missed. Book 2 is trained on those leftovers, so it handles finer detail. Closest page, 891, Pine Forest, Mountains. Subtract again. Book 3, finer still, 2033, Misty Morning Light. Keep going, about 8 books deep, and now your whole painting is 8 page numbers. 147, 891, 2033, and so on. That's the ID. And because every video runs through the same books, the IDs line up. 2 Pine Forest paintings both land on page 891 in Book 2. Shared prefix, different endings. So the ID tells you what neighborhood a video lives in. And nobody designed those books. The system learned them, worked out on its own that Book 1 should hold broad topics and Book 3 the fine details. Nobody labeled page 147 landscape. It just emerged. The technique has a mouthful of a name, RQVAE. The IDs it produces, YouTube calls Semantic IDs, and that's the part worth remembering. Because once every video has one, the whole catalogue organises itself. The first token lands on something broad: music, gaming, sports. Inside sports, it narrows down to, say, volleyball. 2 volleyball clips share those opening tokens and only split at the very end. Across billions of videos, the whole catalogue turns into a vocabulary, and the words are videos. Okay, so now you can turn any video into a short sequence of meaningful tokens, which raises the real question: what do you do with a language nobody speaks? You teach it to something that's already fluent in hours. Gemini. They take a base Gemini, the same model family behind Google's chatbot, and they keep training it to be bilingual, fluent in English and fluent in this new language of videos. They do it with 2 kinds of lessons. First lesson, vocabulary. Show the model a video's semantic ID and have it predict the title, then the creator, then the topics, over and over, billions of times. It's learning what the tokens mean, that this particular sequence is tennis highlights, that one is an AI tutorial. Flashcards between English and video. Second lesson, grammar. Feed it the real watch histories, actual sequences of what billions of people watched, one after another. Hide a few videos in each sequence and make the model guess what's missing. That teaches it how videos go together, how attention actually flows from one to the next. Put both lessons together, and you get a model that reasons across English and YouTube at the same time. The talk has a great example of what that looks like. They show the model 3 videos from someone's history, each one spelled out. Video 1 is interesting to tennis fans because it's about Wimbledon. Video 2, interesting to F1 fans because it's the Spanish Grand Prix. Video 3, interesting to math fans because it's about pi, the number. Then they hand it a 4th video. No title, no description, just the semantic ID. And they ask, who is this one for? The model says technology fans because it's about AI. Sit with that for a second. It wasn't handed the word AI anywhere. It read, this video is about AI straight out of the bare token sequence and matched the pattern of the prompt. That's the whole bet paying off. The ID carries real meaning, and the model reads it straight off the tokens, the same way it reads a word. Which gets you to the actual product. To make a real recommendation, they build a prompt for the specific person. A 24-year-old woman in the US on Android. Right now, she's watching a track highlight from the Olympics, plus her last 50 videos. What she watched, what she commented on, how hard she leaned into each one. Now, what should she see next? The old system had a reasonable answer. She's watching men's track, so it serves up more men's track. That's collaborative filtering. Find the people who watch the same clip, look at what else they watched, recommend that. Which means it can only surface videos that already showed up in someone else's history. The new model reads her demographics and watch history together and recommends the women's races, which never showed up in those co-watch histories at all. And then there's the engineering. Getting this into production came with its own problems, and a few of them are interesting. Start with raw size. Train an English model and your vocabulary is maybe 100,000 words, and it adds about 1,000 new ones a year. YouTube's vocabulary is 20 billion videos, and it grows by millions a day. Different universe. And missing a word costs you completely different things. If Gemini doesn't know Riz, the 2023 word of the year, it still answers 99% of your questions. It misses a joke. Who cares? But if Taylor Swift drops a music video and YouTube can't recommend it for a few hours, that's real users walking away. So you can't retrain on the calm 3 to 6 month schedule a normal LLM gets. You're reteaching this thing fresh vocabulary on the order of days and hours, constantly. Then there's cost. Running a Gemini class model for everyone, every time they open the app, is infeasible. They cut serving cost by over 95% just to launch. The main trick? Most of the watch time goes to a small set of popular videos. For those, they drop the personalization, strip out who the user is, and pre-compute a plain table. Watching video A, here's what's good next. Serving becomes a lookup, no live inference. Normally, dropping the personalization gives you bland, one-size-fits-all junk. It works here because the model came from a giant Gemini checkpoint. Its read on the content alone is sharp enough without knowing you. So they run inference once per popular video, not once per user per session. The real trade-off. One more, and it's the strangest one. Early on, they cared mostly about recommendation quality, so they trained the model hard on the video language and let everything else slide. And it started forgetting English. Bilingual wasn't a metaphor, pushed too far toward videos, and the natural language ability actually decays. Their best guess is that the model might still be reasoning in English somewhere in its middle layers. It's just lost the ability to say the answer in English, so it all comes out as video tokens. The fix they're trying is to split the model up. Some parts stay fluent in English, others specialize in video. Still an open problem. So, zoom out, and the whole system is really just 3 moves. 1, turn every video into a language of its own. 2, take an LLM and train it until it's bilingual, fluent in English and fluent in that video language. 3, build a personalized prompt for each user and let the model generate the recommendations. That's the shape of it. When we started, I called every video a prompt. Really, each one becomes a token, but there is a prompt in this system, the one built around you, the viewer. And part of what goes into it is what you leave in the comments. So I know some of you had fun in the comments section of that prompt injection video, writing little injections just to play along. Maybe YouTube's been piping those straight into an LLM. So if you liked this one, leave a comment. That's a real signal. And maybe, just maybe, if you phrase it right, you could prompt inject the recommendation system itself, convince YouTube to delete its database. Like, subscribe, share, all of it feeds the machine. And now you know a little more about what's on the other side of it.